Okay, the next question is question 21. A cannonball is shot from the top of a 30-meter high hill at a velocity of 25 meters per second and at an angle of 40 degrees above the horizontal and lands on the ground below. The speed of the cannonball at the top of its path is most nearly A, 0, B, 16 meters per second, C, 19 meters per second, D, 25 meters per second, or E, 29 meters per second. So, first of all, it's not going to have any y velocity at the top of its path because it has a positive y velocity as it is going up, and then it goes to 0 at the very top, which is what we're talking about, and then it starts to fall back down. So there's no y velocity at the top, so all we're looking at right now is the x velocity. So we start off with an x velocity of 25, or we start off with a velocity of 25 meters per second at an angle of 40 degrees above the horizontal. So if we want to get the x component of this, we can just say, we can just take 25 meters per second times cosine of 40 degrees times cosine of 40 degrees and because we don't have any forces being applied while the object is traveling in the air in the x direction, we only have a force being applied in the y direction, which is the gravity causing the ball to be accelerating downwards, which is also what causes it to have a velocity of 0 at that one point. And since we're talking about the point where the y velocity is 0, all we need to look at is the x velocity, which is going to remain constant throughout the path of the object's flight because there are no forces being applied to change its velocity. And things do not change velocity unless a force is applied to do so. So that means we can just multiply 25 times cosine of 40 degrees.
It's in radians. No, the calculator's in radians. So you might switch it.
Thank you.
That must have been confusing.
So we have 25 times the cosine of 40 degrees. And that is equal to 19.15 meters per second. So A is 0, B is 16 meters per second, C is 19 meters per second, and that's our answer. If the ball did not have any y acceleration that caused it to eventually hit the ground, and if there actually was no air resistance in this situation, the ball would just maintain that velocity of 19 meters per second about forever, because objects that are in motion tend to stay in motion until a force is applied that causes it to do something else. So that's why we're able to just solve the initial x component of the velocity of this ball, and then assume it's constant throughout the entire flight path of the object.